You are provided with solid P. Carry out the following tests and record the observations and inferences in the spaces provided. Place about 1/3 of solid P in a dry test tube and heat it strongly. Test any gases produced with red litmus paper. So this red litmus paper must be moist. You have to make this litmus paper wet by using distilled water because otherwise it will not, you will not see any change formed. So before even you go through the question, first you have to identify whether this question is inorganic chemistry or it is organic qualitative analysis. How do you do that? You go through the questions. For example, here we have to the first portion, add a solution, add aqueous sodium hydroxide. So the reagent here is sodium hydroxide. You go to the next one, add aqueous barium nitrate. So barium nitrate, now up to this point now, you realize that you are doing inorganic qualitative analysis. Therefore, you know where there's nothing like double bond you are going to write here. This one is inorganic purely. So what will be the observation? So after heating and testing for the gases, this was the observation. Red litmus paper changes blue. That was the first observation. And then white fumes are formed. White fumes are formed. So from here you can say that red litmus paper changes blue. It means that the gas that was produced is a basic gas. That's why now the red litmus paper is changing too. So you can simply say, because we know ammonia is the only gas which is, so the salt which was there must be ammonium ion present. Or you can write basic gas produced. Place the remaining amount of solid P in a boiling tube. Add about 15 centimeters cube of distilled water and shake to dissolve the solid. Use about 2 centimeters cube portion of the solution in test tube for each of the following test 1 to Roman 4. To the first portion of the solution, add aqueous sodium hydroxide. So we are adding sodium hydroxide. And then what is the observation? The observation is that no white PPT is formed. So if no white PPT is formed, we know for sure that the ZAP, that is the zinc 2 ions, zinc 2 positive, lead 2 positive, aluminium 3 positive are absent. That one we know very well that they are absent. If they could be absent, then a white precipitate would be observed. But now there is no white PPT. Now what could be present? We know very well, if we are adding sodium hydroxide and there is no white PPT, then simply it means that sodium ions, potassium ions, and ammonium ions are present. To the second portion of the solution, add 2 or 3 drops of aqueous barium nitrate. So when we are adding barium nitrate, even before you do the test, you should expect a white precipitate or no white precipitate. Because inside there, if there is a sulfate, a sulfite or a carbonate, it will form a white precipitate with barium. You should know all sorts of barium that are insoluble. So the observation is that no white PPT formed. No white PPT formed. So if there is no white PPT formed, what does it mean? It means that the sulfate, which could form barium sulfate, the sulfite, which could form barium sulfite, and the carbonate are absent. So sulfite, carbonate are absent because there is no white PPT. To the third portion of the solution, add 2 to 3 drops of lead nitrate, warm the mixture. So here we are going to make 2 observations. After adding 2 drops, what happened? After warming, what happened? So you should know, once you have been told to warm, observation expected, you have to make observation twice. So after adding lead nitrate, 2 drops, white PPT is formed. A white PPT is formed. White PPT is formed. So we know a white lead will form a white precipitate with the sulfate, with the carbonate, with the sulfite, with the sulfite 2 minus, and with the chloride. So lead sulfate, lead carbonate, lead sulfite, lead chloride, all of them are white precipitates. But remember, even bromine ions, bromide, lead bromide is a white precipitate. Now, remember in the previous inference that we wrote, here in Roman 2, we said that the sulfate, sulfite, and the carbonate is absent. So there is no way they will reappear again in the next test. In Roman 3, they will not reappear there. Therefore, this one, if they are absent here, the subsequent test, they will not be there. Mark that. Therefore, we are not going to write the sulfate, the carbonate, or the sulfite present here. We are going to write that the chloride, even before we write the inference, what happened? Did it dissolve to form a catalyst on warming? Yes. So a white PPT is formed, which dissolve on warming. So that one confirms that it formed lead chloride. Lead chloride is the one, or lead chloride is the one which dissolves on warming. Therefore, lead is present. That means that the chloride ion is present, or the bromide ion is present. We will not write these ones that are present because in the previous we have said they are not there. To solid D in the test tube, add about 2 centimeters of distilled water. Shake and label this solution chlorine water. Add all the chlorine water to the 4th portion of the solution. Shake the mixture and then add 3 drops of starch solution. Starch solution. Here you need to understand the test for starch, which you learned, which is taught in Form 1. Test for starch. How do you test for starch? So test tubes. Okay, suppose this procedure, you should know this. Into a clean test tube, put 2 ml of the food substance. This is the food substance which is suspected to be starch. Add 3 drops of iodine solution. So iodine is used to test for starch. Now, if the starch is present, if the color changes from brown to blue, black indicates the presence of starch. So now, when you have this knowledge, then you will be able to answer the question that is testing us on starch. No blue black color formed with the starch. So if no blue color, that is starch, if no blue color that is formed, And we know we use iodine. We use iodine to test for starch. If the color does not change to black, then it indicates that iodine is absent. Iodine ions is absent. So this one is correct. What if the colorless solution? Now the positive observation is that the colorless solution changes yellow. If it changes yellow, then it means bromide ions are present. So like I've always advised, take what is positive and leave alone what is not there. But this one is, both of them are correct. Remember, whenever you see starch, they are testing for the presence of an iodine ions, because we know from biology iodine is used for the test of starch. Give the formula of the ions present in solid B. The cation is ammonium ion. The anion is bromine ions. You are provided with liquid Q. Carry out the following tests and record the observations and inferences in the space provided. So we have been given a liquid this time around. Place 2 drops of liquid Q on a watch glass. Ignite the liquid with a Bunsen burner flame using a watch glass. Then the observation is that liquid Q burns with a yellow flame. Burns with a yellow flame. That one confirms the unsaturated organic compound. The unsaturated is the double bond and the triple bond present. Or you can write unsaturated compound present. Unsaturated organic compound present. Place about 2 centimeters of liquid Q in a test tube. Add about 2 centimeters of distilled water and shake. So here we want to see whether the liquids are miscible or immiscible, whether they form 1 layer or 2 layers. So the observation is that 2 layers are formed, or you can also say that Q is immiscible in water. If it forms 2 layers, then it means that it is immiscible. So if it is immiscible, then it is an non-polar organic compound present. If it is miscible, then it is polar. If it forms 1 layer, it is polar organic compound present. To about 2 centimeters of liquid Q in a test tube, add all the solid sodium hydrogen carbonate provided. Then no effervescence. If there is no effervescence, then it means that the alkanoic acids are absent. The alkanoic acids are absent. To about 2 centimeters of Q of liquid Q in a test tube, add 2 to 3 drops of bromine water, and then bromine water is decolorized. The bromine water is decolorized by after adding 2 drops, then it means the unsaturated organic compounds are present. Also this one, orange acidified potassium dichromate remains orange. If it remains orange, then the alcohol is absent.